Hello guys, welcome to my channel. Today we are solving this Leetcode problem number 1, the two-sum problem. Let us try to understand what this problem says. Given an array of integer nums and integer target. So we are given an array of integer nums and an integer target, both are integers, and we need to return the indices of two numbers such that they add up to the target. So let's take an example, and it also says that it would have exactly one solution. So that's a boundary, that's a condition that is given to us, so we need not worry about a case where there is no solution, and we can return an answer in any order. Probably there can be multiple answers and we can return any of them. So let's say for example, this is an example here. This array is given 2, 7, 11, 15, and we have a target of 9. So we need to return the indices of, here 2 and 7, they sum up to 9. So we need to return the indices of 1, indices of 2 and 7, which is 0 and 1 as output. Okay. So similarly, this case here target is 6. So we have 2 and 4 can add up to 6. So we need exactly two numbers that can sum up to this target. So here their indices are 1 and 2 respectively, and similarly here 6 is 0 and 1, and there is no false case here. So what is the approach? The first approach is the brute force approach. In the brute force approach, what exactly we will do? We will see all possible combinations of elements that sum up to target n, but the complexity would be high in that case. So what would be the complexity? The complexity of choosing any two integers out of n integers would be nc2, which would be n squared complexity. Okay, can we do it better? Yes, of course we can do it better, but how? Okay, so we can do it in order of n. So how can we do it in order of n? So what we can do first is we can keep a map of all these numbers in a hash with keys as these values, and values of that hash map would be the indices of this number, and then we can iterate through this array again, and we would, at any element, let's say we are at 7 at the moment, we can let's say we are at 2 at that moment, and then we see that we subtract this element from this target, then we get 7. So we can check if 7 is present as a key inside our hash map, and if yes, we can return back its index. And one thing that we want to make sure is, like this case of 3 3, that the index which is present as a value inside our hash map is not exactly equal to this this value against this original index against which we are checking this. So this is one consideration we should keep in mind while solving this problem. Let's try to code it and see how we can make it out. So let's start with the map of integer, so this is a map that we would keep. Let us initialize this map. Okay, so now we have a map. Next, let us start a loop and fill up this map. Okay, so we have this loop ready. Let us fill up this map. Dot put, and we would put nums of I as key and I as value. Okay, now what would we do? We would again iterate through this loop, and this time we would do it slightly differently. So int difference equal to target minus nums of I at that moment. Now we would check if this difference exists inside our map. So map dot contents key. So we would first need to check the contents key, because we don't want to check for null values. Okay, and then we would check if map dot, if this exists, then we would have this value. Okay, and one more condition is this should not be equal to I, which means it should not be equal to the index that we are already checking. So this is one condition then that we should also keep in mind. If this holds true, we would return integer, and here we would just have, okay, it's back, and we would have I and this value which we are returning, which is not equal to I, and we should not type an else condition here, because this would not be correct. If we don't find any, then actually that should not be the case, because as per the problem statement, but we would definitely need to return something. So in this case, let's return an empty array. Let's try to see if it runs correctly. Okay, there is a semicolon that is missing. Okay, no, here it should have a semicolon. Oh, that was a miss. Let's try to run it again. Line number 12. Oh, this was correct, I think. Oh. Oh no, we have an answer. Let's try to submit and see. So we were able to run it in 13 milliseconds, which is faster than 52.6% of all 9 codes. Thank you everyone. See you in the next one.